Okay, we've got two more episodes to go in my 10 ways to disprove flat Earth with common sense. We're on episode number 9, meteor showers and the zodiac. So, how do predictable meteor showers on our zodiac constellations disprove a flat Earth and prove a spherical Earth? Glad you asked. Let's get started. All right, if we take a look at this illustration of meteor showers, the ones that we know, the ones that we can predict, the ones that are on our calendar, you can Google when the next meteor shower is going to be, and you'll see on this illustration here where we are as we circle around the sun, what month we're in, and what meteor showers we're about to come in contact with, or kind of go through or go near to where they're visible. So you see in October, you got the Draconids, November is Leonids, December is Geminids, and so on as we travel around the sun each year. This is around the perimeter of the sun along the ecliptic. We go through these different areas in our travel, and we know that they're going to happen, and we can predict them when they're going to happen. So it's pretty easy on this map to kind of see exactly when they're going to happen and how we know, because the Earth is traveling around the sun and we know in those areas that's where we're going to see them. It's like taking a trip in your car and you know certain things that you're going to pass on your trip. Your vacation trip, your 5 hour, 6 hour trip that you take in your car. If it's something common that you do each year, a couple times a year, you know certain landmarks. Well, these meteor showers are kind of landmarks in Earth's journey around the sun. That's how exactly we know where they are and when they're going to happen. Very similarly are the zodiac constellations. The zodiac constellations are around the ecliptic. So whenever Earth's back is on the sun and we're looking outwards into space along the ecliptic, we see the zodiac constellations. We know it. It's very easy to prove with your own eyes when you look up into the path of the sun and the moon. If you kind of look along that path, that's the ecliptic. If you look dead north, that's where the North Star is going to be. If you look dead south, that's the southern constellations that you're going to see. Southern hemisphere is going to get obviously a better view of the southern sky. They're going to see that famous constellation Octans, the 3-star constellation in almost the center of the southern sky. Northern hemisphere people cannot see that. Northern hemisphere people see the North Star in the dead center of the sky, and the North Star is the last star in the handle of the Little Dipper. So if you look at this illustration, you see Aries, Pisces, Aquarius, Capricorn. You see these different constellations that we're going to see usually in a big dark sky where you can see the whole sky, a lot of stars. You can see 3, maybe 4 of the zodiac constellations at a time. But when it's dead center, that's when we call that's the sign that you're in. If you're in the sign of Sagittarius, that's pretty much when that sign is dead center in the sky along the ecliptic. So if we were to turn this illustration kind of flat, where we're looking at it from the side, you see Earth's travel around the sun, kind of going around the different constellations that we see when our back is on the sun. Now, if we were to look straight up from here, we're going to see the North Star. And it's so big and so far away, it looks like it doesn't even move, even though we're traveling millions of miles around the sun, kind of getting from one end all the way to the other and back. And if you look south from here, you're going to see Octans in the center. Again, only the southern hemisphere gets a great view of that. But these are things that you could see with your naked eye. It's not CGI. It's not illustrations. It's not hocus pocus. When you go out in the night sky, depending on where you are in the northern or southern hemisphere, very predictable what you can see with meteor showers and with the zodiac constellations. Now let's take a look at the flat Earth model, almost comical. So here's flat Earth. It has the famous firmament bubble over the top of it, the big dome over the top of it. Supposedly, the moon and the sun travel around in circles inside of this dome. No flat earther will give you a solid answer on where stars are. Maybe nested in the firmament. The firmament's supposed to be solid, but then they say that there's water up there as well. So Nobody will give you a real answer of where the stars are. But let's just say that the stars are nested inside of the firmament, right? Let's just pretend that for a second. Where would the meteor showers be? And how would we know throughout the year when they're going to happen in this flat earth model? Where do they come from? Where do they go? And how do we know exactly what month they're going to happen in? I've never seen a model. You never will see a model. Nobody will show you an illustration or a model of a flat earth explaining meteor showers and how they're predictable. Nobody on a flat earth model can explain the zodiac signs. They can show you where the North Star is, the dead center of the top of the dome. They don't talk about the southern hemisphere much, don't talk about the southern stars much, don't ever talk about Octans, which is that constellation in the dead center south. We'll never talk about that. Nor will they talk about the zodiac constellations, because there's no flat earth model that can explain how we see the different zodiac constellations along the ecliptic throughout the year. Won't happen. So there you go. Using predictable meteor showers and the zodiac constellations that we see throughout the year. Can't prove that on a flat earth, but you can easily prove it on the spherical model. Peace out.